Hello student, today we will discuss the basic concept of Thevenin's theorem. Then what is Thevenin's theorem? So first we assess through the statement Thevenin's theorem, any two-terminal bilateral linear DC circuit, any two-terminal bilateral linear DC circuit can be replaced by an equivalent circuit which consists of voltage source series with resistance. So according to the Thevenin's theorem, we create equivalent circuit with respect to the any complicated circuit. It can convert into a equivalent voltage and equivalent resistance, and at the end voltage source are connected with the resistance. So we identify the value of I through the equivalent voltage or equivalent resistance. So according to the Thevenin's theorem, any two-terminal bilateral linear DC circuit can be replaced by an equivalent circuit which consists of voltage source with series resistance. So if we are consider one of the numerical So Thevenin's theorem is followed in a two-step. First, identify the equivalent voltage. Second one, equivalent resistance. So if we want to identify current across the AB terminal, current across AB terminal. So in this case, AB terminal is considered as output terminal or maybe load. So AB as an output terminal or maybe load. Now the resistor across the AB terminal RL is equal to the load resistance, a resistance which is connected across the AB terminal. So in this numerical, the load resistance is equal to 2 ohm. So again, a point where we identify the value of current through the Thevenin's theorem is considered as an output terminal. Then that resistance of that point is considered as a load resistance. Then we identify the value of open circuit voltage or Thevenin's voltage through the open circuit of AB terminal. So in the given circuit, five volt, 1 ohm, 1 ohm, and 1 ohm. Or because AB terminal is an output terminal, then it converts into an open circuit. Or then we identify the value of VOC or VTH. So in this case, when terminal AB is open circuit, circuit. So the current across this one of resistance is 0 because the terminal AB is open circuit. So again, the value of VTH directly at this point, VTH. So now through the loop analysis, we apply the loop I or find the value of current. So -5 plus 1 into I plus 1 into I, because current in this loop is 0. So the value of I is equal to the 5 by 2, which is equal to the 2.5 ampere. So in this case, the value of VTH is equal to the 5 by 2, sorry, VTH is equal to the 1 ohm into I. Then value of I is 2.5 ampere. So 1 into 2.5 is equal to the 2.5 volt. This is the value of equivalent voltage or Thevenin's voltage. So now we complete the first part to identify the equivalent voltage. Now go in the second approach to find out the equivalent resistance. So again, 5 volt, one ohm, and 1 ohm. Now we find out R equivalent or Thevenin's resistance at the terminal of AB. Then what is the process to identify the R equivalent? Normally as a series and parallel connection, but after the elimination of battery, maybe voltage source or current source. So when we identify equivalent resistance across the AB terminal, so in that case, voltage source is converted into a short circuit, or current source is converted into a open circuit. Now the question is arise, why voltage source is converted into a short circuit and why current source converted into an open circuit. So the ideal resistance of voltage source is 0. So when the value of resistance is 0, so current is flow in a maximum amount. So the maximum current is equal to the short circuit. The ideal resistance of current source is infinite. So the value of resistance is infinite. So in that case, the value of current is 0. So circuit behaves just like a open circuit. So in this numerical, the 5 volt as a voltage source, so it converts into a short circuit. So now the next circuit is just like this. So 1 ohm, 1 ohm and 1 ohm then are equivalent. So in this case, this one and this one is connected in parallel. So 1 into 1 divided by 1 plus 1, 1 into 1 divided by 1 plus 1 is equal to 1 by 2, which is equal to the 0.5 ohm. So in the next case, 0.5 ohm is connected series with the in the next case 0.5 ohm in this position and 1 ohm is connected at this position. So R equivalent is equal to 1 plus 0.5 is equal to the 1.5 ohm. So the equivalent resistance of AB terminal is equal to the 1.5 ohm. So now we assess the value of equivalent resistance and the value of equivalent voltage. Now we identify the load current. Then what is the meaning of load current? Current across the AB terminal. So the current across the AB terminal or load current is given by Thevenin's voltage divided by Thevenin's resistance plus load resistance. So in this case, the value of Thevenin's voltage, in our last slide, we identify the value of Thevenin's voltage is equal to the 2.5 volt. So now the value of VTH is equal to 2.5. The value of RTH is equal to the 1.5. A value of RL is already as at 2 ohms. The value 2.5 divided by 3.5. So value of load current is 5/7 ampere. So now the equivalent circuit is VTH connected in series with the RTH, or RL load resistance, and the final amount of current is equal to the IL. So this is an equivalent circuit of the given numerical in the terms of Thevenin's theorem.